We're going to talk about speed adjustments, a subject that often causes confusion in radar classes. But hopefully by the end of this episode, you'll understand what speed adjustments are, why you might use them, and how to correctly apply them. So let's start by talking about speed. As you've probably noticed by now, the aviation world expresses speed in knots, as opposed to miles per hour or kilometers per hour. Why? It's a throwback to around the 17th century. At that time, vessels traveling the world's oceans commonly measured speed with a rope line that had a weighted piece of wood tied to one end. The rope had a series of knots tied in it at regular intervals. Sailors would throw the rope overboard and count how many knots passed through the line over a predetermined time period, and would derive the ship's speed based on that measurement. The terminology stuck. A knot is a unit of measurement that is equivalent to 1 nautical mile per hour, approximately 1.15 statute miles per hour, which is the same kind of miles per hour that your car's speedometer measures. And in case you're wondering why most distances in aviation are measured in nautical miles, that too is a throwback to the days of sailing ships, and it was actually a very practical measurement. A nautical mile is equal to 1 minute of arc of latitude along a meridian, which made it easy for navigators to determine their position on the Earth's surface by using established methods of timekeeping and speed measurement. Since aircraft also measure position relative to the Earth's surface, it made sense to measure distances the same way. New technologies such as GPS and area navigation, or RNAV, are now standard on most aircraft, but the traditional measurements and terminology are still in use. Information governing speed adjustments can be found in the 7110.65 in Chapter 5, Section 7. We'll start by going over some general information provided in this section. The first statement lays out the basic framework for using speed adjustments. Keep speed adjustments to the minimum necessary to achieve or maintain required or desired spacing. Avoid adjustments requiring alternate decreases and increases. Permit pilots to resume normal speed when previously specified adjustments are no longer needed. All that is pretty self-explanatory, but the note which follows is pretty important to understand. It is the pilot's responsibility and prerogative to refuse speed adjustments that he or she considers excessive or contrary to the aircraft's operating specifications. In other words, the pilot can refuse to abide by a speed adjustment that will result in the aircraft slowing beyond its stall speed or minimum controllable airspeed, or that will take it beyond its structural cruising speed or never exceed speed. Each of these speeds can vary depending on aircraft weight and atmospheric conditions, which is why it's up to the pilot to make this determination. Pilots must advise ATC if they cannot accept a speed adjustment. The 7110 lists some factors to keep in mind when issuing speed adjustments. First, aircraft do not speed up or slow down on a dime. So understand that when you tell an airplane to slow down or speed up, it may take a few moments to reach the new speed. Because of this, you may need to start slowing down an aircraft sooner than you think, especially when it is in trail with other aircraft. More on this a little bit later. Next is altitude. The higher an aircraft is, the faster it goes, due to its vertical distance from the surface and decreased air resistance at high altitudes. Your radar display shows you an aircraft's ground speed, which is not necessarily the same thing as its speed through the air, and the difference between ground speed and airspeed increases as the aircraft climbs higher. Consider this example. An aircraft at 5,000 feet is showing 268 knots on your radar, although the pilot sees 250 knots on the airspeed indicator. What the pilot sees on this instrument is referred to as indicated airspeed. Now let's move the aircraft to flight level 280. The indicated airspeed does not change for the pilot, but on your radar display, the aircraft's ground speed now shows 381 knots. There are some other factors, such as winds aloft, that can influence the difference too. For example, a 20-knot headwind would reduce an aircraft's ground speed, but the indicated airspeed would not change. There's nothing a pilot hates more than having to speed up, speed up, and slow down again, so keep the adjustments to a minimum. Finally, the law of gravity dictates that it's extremely difficult for aircraft, especially jet aircraft, to slow down in a descent. So either issue the speed adjustment before issuing a descent, or wait until the aircraft levels off and issue the adjustment then. Coming up next, we'll look at some specific techniques for using speed adjustments and the correct phraseology for issuing them. True or false? The pilot must abide by a speed adjustment issued by air traffic control. The answer is false. Pilots do not have to abide by a speed adjustment if it would exceed any of the aircraft's performance capabilities. What factors influence an aircraft's ability to change speed? A. Altitude, B. Weight, C. Current speed, or D. All of the above? The answer is D. All of these factors influence an aircraft's performance capabilities. Now let's take a look at the rules for using speed restrictions, along with a few examples of how to correctly apply them. As a general rule, it's better not to use speed restrictions unless you have a good reason to. Reasons to use them include slowing or speeding up aircraft on downwind for sequencing with those of the other controller, matching speeds to maintain separation on final, and maintaining desired spacing between aircraft in a box pattern or on downwind. Slowing aircraft just to reduce your workload can get you into trouble. For example, if you slow all of your traffic on downwind, the controller working the other approach sector will have to slow his or her aircraft as well in order to sequence the traffic. Also, if you slow all your traffic on final, the other controller must do the same. A big reason for loss of separation in class is mismatched speeds on final. So you can see that by reducing your workload, you may have increased someone else's. Also, the farther out from Academy Airport that you start slowing traffic, the greater the impact it has on Aero Center. They may be forced to slow down all their traffic so it doesn't get bunched up at the arrival gates. Or they may not slow their traffic and you will end up with a big mess in your sector as more arrivals come before your existing traffic gets to the airport. You can coordinate speeds with center, but again, slowing traffic down creates a ripple effect through all of yours and center's airspace, so use speed adjustments sparingly. The 7110.65 gives specifics on how to correctly apply speed adjustments. First, if you have a line of aircraft, reduce the trailing aircraft first, or increase the leading aircraft first. This assures separation because it prevents one aircraft from overtaking the other. Let's see what happens if we reduce the speed of the leading aircraft first. You can see that the trailing aircraft begins to catch up, but if you are busy, you may not notice until it's too late. Second, assign a specific airspeed if required to maintain spacing. For example, you may decide that all aircraft turning onto downwind should maintain 300 knots in order to keep adequate spacing. There is one situation in which you cannot issue a speed adjustment. Inside the final approach fix on final or a point 5 miles from the runway, whichever is closer to the runway. The reason is simply that by this point the pilot has to begin slowing for landing and cannot accept any further speed adjustments. There are some other limits to what speeds you can issue as described in paragraph 3. To aircraft operating between flight level 280 and 10,000 feet, a speed not less than 250 knots. However, when an operational advantage will be realized, speeds lower than the recommended minima may be applied. Now for what concerns us the most. To arrival aircraft operating below 10,000 feet, turbojet aircraft, a speed of not less than 210 knots, except when the aircraft is within 20 flying miles of the runway threshold of the airport of intended landing, a speed not less than 170 knots. Reciprocating engine and turboprop aircraft, a speed not less than 200 knots, except when the aircraft is within 20 flying miles of the runway threshold of the airport of intended landing, a speed not less than 150 knots. Flying miles means the actual distance the aircraft will fly to get to the runway, not the straight line distance from its current location. If an aircraft is abeam the approach end of the runway, the flying miles include the distance it will fly on downwind, the base turn, and final approach all added together. There are limits for departing aircraft too. Departures, turbojet aircraft, a speed not less than 230 knots. Reciprocating engine and turboprop aircraft, a speed not less than 150 knots. Helicopters, a speed not less than 60 knots. Let's talk about speeds on final for a minute. Paragraph 1, number 4D is important to know. It says, approach clearances cancel any previously assigned speed adjustment. Pilots are expected to make their own speed adjustments to complete the approach unless the adjustments are restated. So if you have an aircraft maintaining a certain speed for a reason and you need it to continue to maintain that speed on final, you must reissue the speed adjustment after you issue the approach clearance. And remember that by regulation, civilian aircraft cannot exceed 250 knots below 10,000 feet. Finally, since you know aircraft on final will be slowing down for landing, you must build in additional space behind them to compensate. Jet aircraft will normally begin slowing down about 8 miles from the runway, and will slow down further once they reach the outer marker. Paragraph 2 lays out the methods and phraseology by which you can issue speed adjustments. Speeds are always issued in 10-knot increments of indicated airspeed, and they are always read as single digits. Instruct aircraft to maintain present or specific speed. This is done by saying maintain present speed or maintain the specific speed, knots. If you're not sure of an aircraft's speed, ask the pilot by saying, say airspeed. Here's an example.
Flagship 2819, 8 miles from Woody, turn left heading 310, maintain 3,100 until established on the localizer, cleared ILS, runway 28 right approach, maintain 220 knots until Woody.
Left heading 310, 3,100 until established on the localizer, cleared ILS, runway 28 right approach, maintaining 220 knots until Woody, Flagship 2819.
Maintain specified speed or greater or less. The phraseology is maintain specific speed, knots or greater, or maintain the specific speed, knots or less. If you have a specific maximum speed in mind, you can say, do not exceed whatever the speed is, knots. Let's listen to a couple examples.
Western Express 110, maintain 300 knots or greater, contact Academy approach 120.2.
300 knots, over to approach, Western Express 110.
United 621, maintain 280 knots or less, contact Academy approach 120.2.
We'll be at 280 or less, 120.2 United 621.
Maintain the highest or lowest practical speed. For this method, you can instruct the pilot to maintain maximum forward speed. Remember that if the aircraft is below 10,000 feet, 250 knots is the fastest a civil aircraft can legally go. You can also say maintain slowest practical speed, but keep in mind that depending on where the aircraft is on final, it may already be at its lowest practical speed. Let's take a listen.
November 224, maintain maximum forward speed until Woody.
Maintaining maximum forward speed until Woody, number 224.
KLM 663 Heavy, maintain slowest practical speed until Woody.
Roger, maintaining slowest practical speed until Woody, KLM 663 Heavy.
Increase or reduce to a specified speed or by a specified number of knots. To issue a speed adjustment in this way, say increase or reduce speed to specified speed in knots, increase or reduce to the specified speed in knots, knots, or increase or reduce speed to the specified number of knots, knots. Note the differences in phraseology. Here are some examples.
UPS 671 Heavy, reduce speed to 250.
250, UPS 671 Heavy.
USR 880 Heavy, reduced to 300 knots.
300 USR 880 Heavy.
Eagle Flight 135, reduce speed 30 knots.
Reducing 30 knots, Eagle Flight 135.
If a speed adjustment that you issued is no longer necessary, say resume normal speed. The pilot will increase or decrease to whatever the normal speed would be for that given situation. Coming up next, we'll take another look at the material from this episode. If a jet aircraft is more than 20 flying miles from the airport, what is the lowest speed you may issue to it? A. 250 knots, B. 210 knots, C. 170 knots, or D. 150 knots. The answer is B. 210 knots. What happens to a speed adjustment once an approach clearance is issued? A. It remains in effect. B. It is reduced by 40 knots. C. It becomes optional on the part of the pilot. D. It is automatically canceled. The answer is D. Speed adjustments are automatically canceled when an approach clearance is issued and must be restated if needed. Now for a quick review. Speed adjustments should be kept to a minimum. Aircraft may need time to speed up or slow down, so allow time for this to happen when issuing a speed adjustment. Your radar display shows ground speed, but the pilot's instruments show indicated airspeed, which is not necessarily the same thing. The higher the altitude, the greater the difference. When in doubt, ask the pilot to say airspeed. Aircraft cannot slow down easily in a descent. Issue a speed adjustment before issuing an altitude change. If aircraft are in trail, slow the trailing aircraft first, or speed up the leading aircraft first. You can also assign a specific speed if you want to maintain certain spacing between aircraft. You cannot issue any speed adjustments when an aircraft has passed the final approach fix or is 5 miles from the runway, whichever point is closer. There are some limits to the speeds you can issue. Aircraft above 10,000 feet should not be slowed to less than 250 knots. Civil aircraft below 10,000 feet cannot exceed 250 knots. Below 10,000 feet, jets should not be slowed to less than 210 knots unless they are within 20 flying miles of the airport, in which case they can be slowed to 170 knots. Turboprops and reciprocating engine aircraft should not be slowed to less than 200 knots unless they are within 20 flying miles of the airport, in which case they can be slowed to 150 knots. For departures, turbojet aircraft should not be slowed to less than 230 knots, turboprops to less than 150 knots, or helicopters to less than 60 knots. Approach clearances automatically cancel any speed adjustment. If you want the adjustment to continue, you must